Here is the first example. You can pause this video and see how you are going to analyze this dataset. Notice that we are looking at the same 5 people using before and after time period. This means this is dependent samples. To reproduce the same result as you see in page 20, what you need to do is first enter this first row in the first column in StatCrunch, second row in the second column of StatCrunch. Then you click on Stats, T-Stats, and we are using paired data, so we click paired. The first group, which is sample 1, will be before, and sample 2 will be after. And we are going to click on Save the Differences. And we want to see the confidence interval for μd, which equals to the μ1 minus μ2. And I will click Compute. So from this window, you will see this result is identical to what you have seen in page 21. And to reproduce the page 20, you want to click on Stats, Summary Stats, and the columns. You hold Shift button and click the Before. And do not release your Shift button. And you click on the Differences. And you can release your Shift button and single left click the option Min and click Compute. You will have identical results in page 20. Again, this window represents identical results in page 20. So how should we interpret the 95% confidence interval, negative 0.36 and negative 0.05? So the group 1 is the data before the treatment, and the group 2 is the data after the treatment. And we are interested in the population mean difference, μd. Since the entire interval is negative, we know the mean of group 2 after treatment was higher. So we are 95% confident that the population mean lung function after the treatment is at least 0.05 and at most 0.36 units greater than the population mean lung function before the treatment. Here is example 2. We are interested in whether there is a difference in the mean age at which man marry and the age at which woman will marry. The following data was collected from a sample size of 24 couples. First, we know that it is dependent samples because husbands and wives are 2 different groups, but since we are looking at them as a couple, as a husband is matched with his wife, so it is paired data. Here's what we know. We let group 1 represents husbands and group 2 represents wives. Now we are looking at the μ1 minus μ2. The negative value means the higher age for wives. Positive values shows higher age for husbands. You can use StatCrunch to get the sample means and the dot plots like this one. From dot plots, the trends of the difference, I'll say, is hard to tell, but you can always compare the sample means. Because the sample means in the group 1 is larger than the sample means for group 2, I will say the mean age for wives is higher. To test whether there is a difference at the 0.1 level of significance, what you want to do is first you have to know the hypothesis. So the alternative hypothesis will be whether the mu d, the alternative hypothesis will be mu d doesn't equal to 0. And here is the StatCrunch output. Since the p-value is 0.0688, which is less than 0.1, we can claim that there is enough evidence to claim there is a difference between husband and wife's age when they got married. You can read this slide by yourself. Next, we want to compute and interpret the 90% confidence interval on the mean difference between the husband's and the wife's age at marriage. We also do it in StatCrunch. Try to reproduce this result by yourself. I have shown you how to use StatCrunch in the example 1. If you cannot reproduce this result, you can send me an email and we can arrange an office hour. The correct interpretation for this confidence interval will be where 90% confidence that the mean age at which men marry is at least 0.19 and at most 3.6 years greater than the mean age at which women marry.